All right. So, quick reminder about absolute value. The absolute value of a number is the distance from zero on the number line. So, absolute value cannot be negative. It must be positive or zero. It cannot be negative. So, the definition of absolute value can be used to solve equations that contain absolute value expressions by constructing two cases. Every time you solve an absolute value equation or inequality, you must construct two arguments, which basically means you're going to write two separate equations for every single one of these problems. Because for any real numbers, a and b, so if a and b are numbers, the absolute value of a equals b. If the absolute value of a is equal to b and b is greater than or equal to 0, then a equals b, or a equals the opposite of b. Let me explain. If you have the absolute value of some number, and that absolute value happens to equal 7, what is the value of x? What's that? 7. Okay. What's that? Or -7. Yeah. There are two answers for this right here, because if you think about what this is saying, is it saying the absolute value of what number equals 7? It's not saying the absolute value of 7, because that's not what's in the absolute value bars. It's the absolute value of some number is equal to 7. And if you think about how that works on a number line, absolute value means distance from 0, right? So if we got 0 here, it's saying that the distance from 0 is 7. Well, that's one of the numbers that has the distance from 0 of 7. And then here's the other number that has the distance from 0 of 7. Because if we go down here for a second, if we say that the absolute value, obviously the absolute value of 7 equals 7, but the absolute value of -7 is also equal to 7. Meaning that if you're trying to figure out the absolute value of some number and the answer is a positive number or 0, well, if it's a positive number, there should be two options for what that value could be, because there are two options for distance from 0 for every single real number. You can go positive or negative. What if I were to ask you this, just as a side question, because you might run into this on your assignment today. Absolute value of x equals -2. Any thoughts on that one? No. All right, it landed on the back strap. It's fine. All right, what do you think? Absolute value of x equals -2. What number is -2 away from x on the number line? What's that? So how far away is 2 from 0 on the number line? How far away is -2 from 0 on the number line? 2. How far is -2 away from 0 on the number line? There is no real number such that the absolute value is equal to -2. This would be no solution.
Wait, why?
Because the absolute value of a number cannot equal a negative.
So if there's any number like that, it's just
What's that?
if for like any equation that is like that,
Yeah.
has a negative number, it's just no solution.
If you isolate the absolute value and it says it's equal to a negative, there can't be a solution.
What if it's like x plus the number?
You would still be saying that the absolute value of that thing is equal to a negative, which doesn't work.
So as long as it's between negative, there's no-
Correct. Now, if you do this, there would be a solution because the absolute value is no longer isolated. And you'd have to divide both sides by -2. And if you divide both sides by -2, you get that. In which case, the answers to this one would be -1 and 1, because there are two numbers that have an absolute value of 1. But there are no numbers that have an absolute value of -2. All right. So let's work with this a little bit. So what this is saying is that if the absolute value of A is equal to B, and the number that the absolute value is equal to is either 0 or greater than 0, it has to be greater than or equal to 0. It cannot be negative. Inside an absolute value absolutely can be negative, because you would take the absolute value and then you make it positive. Once you've taken the absolute value, you cannot have a negative number. A is equal to B, the positive version of this number here, or what's inside the absolute value could also be the opposite of that, because you can have a negative inside the absolute value. So, steps here. It's basically solving a regular equation. But the first thing you need to do is isolate the absolute value expression. Everything looks normal. You're just basically treating the absolute value bars as a group, but you cannot distribute into them. So they're not parentheses, so you can't distribute into them. You can divide away from them and all that kind of stuff, and we'll see that as we go through this. So you're going to isolate your absolute value expression on one side of the equation. Then you're going to write two cases. The first case will be equal to just the normal positive version. The second case will be equal to the opposite version. And then you're going to use the properties of equality, so basically just solve both. And then check your solutions. Plug them back in, make sure they work with the original. So absolute value equations might have 1, 2, or no solutions. So 2 solutions is going to be if the value is positive on the inside, or it equals a positive value when you take the absolute value. How can it only have one answer? What would the case be if it's equal to only one number? Because absolute value is distance from 0. It would be 0, yeah. Because 0 is its own opposite. It's not positive or negative. And so the only way that you could have a single solution is if the absolute value equals 0. So an absolute value equation has one solution, it tells you right here, has one solution if the answer does not meet the constraints of the problem. Such an answer, okay. There are also other instances when it's not 0, but if one of the answers does not meet the constraints of the problem. So this is why you have to check your answers, by the way. Sometimes when you get an answer and you plug it back in, it doesn't work. And so if you check your answers and one of them doesn't work, that's what's known as an extraneous solution, meaning it's an answer, but it doesn't actually work, so we can't consider it to be an actual answer. And we'll see examples of that too. An absolute value equation has no solution if there is no answer that meets the constraints of the problem. Generally speaking, it means it's equal to a negative, which doesn't work. The solution set of this type of equation is called the empty set, symbolized by 2 braces where there's nothing in it. It doesn't equal anything, or just a 0 with a slash through it. There are no numbers that work. Or you could write no solution. All right. Problem number 1. First thing we need to do before we write our 2 separate equations is to whittle this down so we get the 5x plus 1, the absolute value of 5x plus 1, by itself on one side of the equation. You have to isolate the absolute value. So here's our equation. And the first thing that it's telling you to do is add 9 to each side, because there's a -9 here. So we're going to add 9 to both sides, and 17 plus 9 is 26. Once you do that, we have to get rid of the multiplication of 2 here. You cannot distribute into absolute value, which means you have to divide both sides by 2 to get rid of the multiplication of 2, which means we divide both of these by 2. 4 divided by 2 is 2, so that's 2x. 26 divided by 2 is 13. So far we've done 2 things. We've added by 9, we've divided by 2. Okay. Now, everything inside the absolute value bars has to be equal to 2x plus 13. There are 2 cases for which this is equal to that. Everything inside of here is either positive or negative, right? This is a number. Whatever x is, we're going to plug it in, and whatever's inside of this absolute value bar is a number, right? Some number. If that number is positive, if everything in here is equal to a positive value, then it's just the distance from 0. However, everything inside of here could also be the opposite of that, because that's possible with absolute value. So case 1 is 5x plus 1 equals 2x plus 13. Everything inside of here could equal 2x plus 13. However, everything inside of here could also be equal to the opposite of that, kind of like we saw here. Whatever produces a positive value means that there are two options inside of here, because both the positive and the negative version of that, if plugged into here, produce this answer. And so that's what we're dealing with. The positive and negative version of this, if put inside the absolute value, produces the positive version of this. So the opposite of this means we're going to take the opposite of everything, negative here and negative here, not just the negative 2x, negative 2x minus 13. Everything changes to its opposite. If it's just a single value, you change it to its opposite. If it's multiple values, everything gets changed to their opposites. Any questions so far? All right, then we're just going to solve both. So subtract 2x from both sides, you get 3x plus 1 equals 13. And then solve the rest of it. Subtract 1 from each side, 3x equals 12. I'm just going to squeeze that in right here. Divide by 3, what does x equal? 4. So x equals 4. That's one of the solutions. Now the other one happens when you solve this one. Add 2x to both sides. That's 7x. When you add 2x to 5x plus 1 equals negative 13. Then we would subtract 1 from both sides, which would be 7x equals negative 14. Divide by 7, what does x equal over here? Negative 2. So the check step. We're going to check both of those solutions to make sure they both work. Everywhere you see an x, you're going to substitute in a 4. So here's the original equation. We have an x on both sides of the equation. We're going to use the original equation, and we're going to plug in a 4 for each of those. And so right here it is. 2 times the absolute value of 5 times 4 plus 1 minus 9 is equal to 4 times 4 plus 17, question mark. Let's find out. 5 times 4 is 20. 20 plus 1 is 21. The absolute value of 21 is 21. 21 times 2 is 42. And 42 minus 9 is 33. Over here, 4 times 4 is 16. 16 plus 17 is 33. Both sides equal 33, which means it's true, which means 4 is definitely a solution. Over here, 5 times negative 2 is negative 10. Negative 10 plus 1 is negative 9. The absolute value of negative 9 is 9. 9 times 2 is 18. 18 minus 9 is 9. On this side, 4 times negative 2 is negative 8. Negative 8 plus 17 is 9. Both sides equal 9. That one's true as well. Yeah.
So when you're solving like an equation or like an absolute value like this, you have to get both values of it.
Yes. Yeah. Because otherwise, the solutions are incomplete. If there's more than one answer, we need all possible solutions. And most of the time, not all the time, but most of the time with absolute value, there are 2 solutions. So, because both solutions make the equation true, that means that the solution set is the value of both 4 and negative 2. So, there it is. Not an inequality. These are the only 2 values that work. There are no lines or arrows that go on this number line. It's just saying that those 2 values, when plugged into this particular equation, both work. All right. Also, reminder, I mentioned this here, to make everything its opposite. For case 2, this one right here, remember to use the distributive property to multiply the entire expression on the right side of the equation by -1. So basically, taking the opposite of everything is using the distributive property and multiplying everything by -1. Any questions before we look at the second? Okay, turn the page. I want you to try this one. Use the margin over here if you need to have some more space, which you probably will need some more space. So go ahead and use that left-hand margin to solve this one, and then put your two solutions on the graph if there happen to be two solutions. And then take about 2.5 minutes maybe on this one. All right, how are we doing so far? So if you want to check the solution set here, 3 and -5. Yeah, all right, let's see why. First of all, we need to isolate our absolute value, which takes one step here. We just have to add 6 to both sides to make that happen. So that'll be the absolute value of 5x minus 3 is equal to -2x plus 18, because you'd add the 6, 12 to make 18. All right, so you've got two cases. The first case is just 5x minus 3 equals -2x plus 18. So let's solve that. I'm going to do that over here. 5x minus 3 equals -2x plus 18. We'll add 2x to both sides. That'll be 7x over here. We'll add 3 to both sides. That'll be 21 there. We'll divide by 7. X equals 3. That's the answer for the first one. Now, the second one is we're going to take everything inside the absolute value and take the opposite of both of those things there, which would be positive 2x minus 18. So the second case is going to be 5x minus 3 equals 2x minus 18. So we're going to subtract 2x from both sides, and that'll be 3x. And then if we add 3 to both sides, that'll be -15. And if we divide by 3, that means x is equal to -5. So our two solutions would be 3 and -5. Any questions there? Before we do a little bit of a check step to make sure they both work with the original equation? Got 3, we got -5. There they are on the number line. So if we check with 3 here real quick, 5 times 3 is 15. 15 minus 3 is 12. The absolute value of 12 is 12. 12 minus 6 is 6. So the left side is 6. Negative 2 times 3 is negative 6. Negative 6 plus 12 is 6. So 6 over here, 6 over here. 3 is good. For negative 5, 5 times negative 5 is negative 25 minus 3, which is negative 28. Absolute value is 28. 28 minus 6 is 22. So the left side is 22. Negative 2 times negative 5 is 10. 10 plus 12 is 22. Both sides equal 22. Both answers work. All right. You don't have to show that check step, but use a calculator, mental math, whatever, just to make sure that it actually works, because sometimes both answers don't work all the time. So let's take a look at when that happens. Unless we have a question before we move on to example 2. Any questions? Example 2. 2 times the absolute value of x plus 1 minus x is equal to 3x minus 4. So we're going to isolate the absolute value, add x to both sides first. We get a 4x. 3x plus x is 4x minus 4. Divide everything by 2. So 4x divided by 2 would be 2x. Negative 4 divided by 2 is negative 2. So we get x plus 1 equals 2x minus 2, absolute value of x plus 1. Our first case, the inside of the absolute value is equal to the regular version of this. So this is just going to be 2x minus 2. Over here, it's equal to, oh, this is making us do parentheses. So 2x minus 2. All right, so then it'll be negative 2x plus 2. Okay. It's having us use the distributed property to show that step. But you don't have to do that if you don't want to. You can start on this one. All right. So solving, if we, looks like they're subtracting x from both sides first. So that'll be x minus 2. And then they're adding 2 to both sides. So one of the answers would be x equals 3. And then over here, it appears that they're adding 2x to both sides. Then we need to subtract 1 from each side. So that would be 3x equals 2 minus 1, which is 1. And then if we divide both sides by 3, that would be 1/3. So our two answers are 3 and 1/3. Those are 2 separate solutions. And now we have to test both of them to make sure. So there appear to be 2 solutions of 3 and 1/3. And this is why you can't just sit back and say, cool, I got it, we're good. Because if you check your answers, first of all, let's check with 3. With the original equation, that would be the absolute value of 3 plus 1, which is the absolute value of 4. 4 times 2 is 8. 8 minus 3 is 5, so 5 there. 3 times 3 is 9. 9 minus 4 is 5, so 3 works. That's good. However, if we check our answer of 1/3, 1/3 plus 1 is 1 1/3, which is 4/3. 4/3 times 2 is 8/3. 8/3 minus 1/3 is 7/3. So 7/3 on the left. Over here, 3 times 1/3 is 1, and 1 minus 4, sorry. Yeah, 1 minus 4 is negative 3. That's good. So 3 times 1/3 is 1, 1 minus 4 is negative 3, which is not equal to 7/3, which means those 2 sides don't match up. 7/3 is not equal to negative 3, which means the only solution is 3. Thus, the solution set is 3. Only one answer. Both of our possible solutions didn't work. So this will be the trickiest thing that you'll run into. So you got to make sure that you have to check your solutions because, I mean, you probably assume that, hey, I got them both solved for, they're both fine. Checking your solutions with absolute value is really important. Okay, next one, the empty set. It means there's no solution. So these ones, I think, will be a little bit more obvious. I hope. If you get the absolute value isolated, you end up having to subtract 10 from both sides. What's 2 minus 10? 2 minus 10? Negative 8. We saw with this one right here that an absolute value cannot equal a negative number, right? There are no variables over here to test for. This is just a number. And it says it's -8. Absolute value cannot equal a negative. So if you run into a situation where you've got something equal to a negative and there's no variable or anything over here, you know that there can't be a solution because the absolute value of any number is always positive or zero, which makes this sentence is not true. So the solution is the empty set. You could also say no solution. All right. I want you to work on all 4 of those ones at the bottom. You need to carve out some room somewhere, that's totally fine. You need to use up here or down here or up here, that's fine. But work on those 4 problems real quick. If you get solutions, make sure you check your solutions. So you can absolutely do it on a different piece of paper. That is totally fine. If you want to try to fit it in around the margins of the notebook, that's fine too. I'm going to give you 5 minutes. So at 8:53, we'll come back and we'll check in, and we'll do that one last example 4 over here, and then we'll call it a day for the notes, and we'll have some time to work on stuff. We'll do the inequalities tomorrow.
So I had a question
Mhm.
about, what is this one?
Yeah.
You can just like, because I think you put like a positive, you can do that. You can just like, for 2 cases.
You mean like down here?
Yeah, because there's negative here and there's no negative.
Because there's always 2 possibilities with these, because everything inside the absolute value could equal exactly what it is here, or it could equal the entire opposite of that. Because absolute value could be positive or negative if it's inside of it. And so one of the first case is always whatever's in here is exactly equal to that. The second one is whatever's in here is equal to everything opposite of this. So in this case, it would be the opposite of 2x, which would be -2x. Then it'd be the opposite of 13, which is -13. You just take the opposite of everything. So then over here, everything inside 5x minus 3 is equal to exactly that, which is this case here. Or everything inside 5x minus 3 is equal to the opposite of both of those things, which would be a positive 2x and a -18. And then you solve for both of them. Yeah. As soon as the bill gets back, I'll figure it out. Um, 51. Yeah, it'll be right side up. That's fine. Let's see. All right. So, have a look. So we got some answers here. For A, there was an extraneous solution on A, so the only answer that works is 6. Any questions on that one that we need to take a closer look at? Be happy to show the work if we need to see it. There's two quick equations, and I'll just go ahead and do those up here. So I'm moving them on up. There's nothing we need to do to isolate anything here. So we're just going to have case 1, which is x plus 10 equals 4x minus 8. If we subtract 4x from both sides, that'll be negative 3x. And if we subtract 10 from both sides, that'll be negative 18. And if we divide both sides by negative 3, that means x is equal to 6. The other case would be x plus 10 is equal to the opposite of both of those things. So it'd be negative 4x plus 8. If we add 4x to both sides, that'll be 5x. And if we subtract 10 from both sides, that will be negative 2. And if we divide both sides by 5, that would be x equals negative 2/5. So the two potential answers are 6 and negative 2/5. If we plug in 6, let's just do that here. 6 plus 10 is 16. So absolute value of 16 is 16. Left side equals 16. 4 times 6 is 24. 24 minus 8 is 16. So both sides are 16. 6 definitely works. If we say negative 2/5, negative 2/5 plus 10 would be 48/5. And 48/5 is, that's our fraction. If we go over here and we multiply 4 times negative 2/5, that would be negative 8/5. And then negative 8/5 minus, this would be 40/5. That would be negative 48/5. So we got, I think it's 48/5. 48/5 and negative 48/5 are not the same thing. Therefore, negative 2/5 does not work for a solution. So it's just 6. Yeah.
Is there ever a time where it doesn't work, but it's not a fraction? Like the whole number.
Probably. We haven't seen it yet, but yeah, I would say it's certainly possible. For B, this one has a little bit of work to do to get the absolute value isolated. So we would subtract 1 from both sides to make this 12 over here. Then both sides would have to be divided by 3. So that would be 9x divided by 3, which is 3x. And then 12 divided by 3 is 4. So our first case is going to be 4x minus 11 equals 3x plus 4. That's case number 1. If we subtract 3x from both sides, that's just x. If we add 11 to both sides, that's 15. So x equals 15. That's our first potential answer. The second case is going to be 4x minus 11 equals the opposite of both of those, negative 3x minus 4. If we add 3x to both sides, that's 7x. And if we add 11 to both sides, that's 7. And if we divide both sides by 7, 7 divided by 7 means x equals 1. And if you plug both of those in, they end up both working. So 2 answers, 1 and 15. For C, you'd have to add 18 to both sides, which would be 2x plus 5 is equal to 15. So we're going to have 2 cases here. The first one is 2x plus 5 equals 15. I'll just go ahead and write this underneath here. 2x plus 5 equals 15. And if we subtract, I wrote 15. 2x plus 5 equals 15. If we subtract 5 from both sides, it'll be 2x equals 10. Divide both sides by 2, and x equals 5. That's one of our solutions to that one. The other case would be 2x plus 5 equals the opposite of 15, which would be negative 15. So 2x plus 5 equals negative 15. Subtract 5 from both sides. That'll be negative 20 over here. That'll be 2x there. Divide by 2, x equals negative 10. And if you substitute both of those back into the original equation, they both work. For the final one, there's not a whole lot to do here because to get the absolute value isolated, you'd subtract 3x from both sides, which would cancel both of the 3x's out, leaving you with negative 5 times the absolute value of 7x minus 2 equals 10. And if you divide both sides by negative 5, that would be the absolute value of 7x minus 2 is equal to -2, which can't work because absolute value cannot equal a negative, which means no solution, empty set. Yes.
You have to put it in.
Not necessarily. I'm not going to be too picky about that. I'm writing it because we're talking about a solution set, and the way that we denote a set is with the braces. But no, if you don't use them, I'm not going to be super picky about that. All right, any questions on A, B, C, or D before we move on to the very last example? So, example 4, talking about football, inflation pressures. This reminds me of, oh gosh, it's probably been a while now since the New England Patriots got in trouble for like having some of their footballs outside of the regulated pressures to increase grip, but that was a big scandal back in the day. All right. The NFL regulates the inflation or air pressure of footballs used during games. It requires that footballs have an air pressure of 13 pounds per square inch, 13 psi, plus or minus 0.5 psi. So that means it could go down to 12.5 or up to 13.5, depending on which side of that it is. What is the greatest and least acceptable air pressure? Well, we just said it. I mean, there's not a whole lot of work to do here. Honestly, this is a weird question. Because you can just add 0.5 or subtract 0.5. Like it's, there's 2 little math problems that need to be done. Anyway, describe the task in your own words. List any questions that you may have. Well, the task is figure out the acceptable air pressure. If you want to write that, you can. If you don't want to write that, don't worry about it. This is a lot of space to do a very simple math problem. How will you approach the task? What have you learned? We are going to use absolute value, though, in order to solve this. So, if we were to actually set up an absolute value equation, this is, I mean, honestly, the math is really simple, but like if you try to craft this in a way that's going to work with absolute value, does anybody have any thoughts on how that's going to work? Any thoughts on how to write an absolute value equation to make this work? Nearly. I would argue that the absolute value of 13 is equal to 13. But we are going to use the absolute value of something. It is going to equal 0.5, which means we need to go ahead and figure out a variable to include, right? We do need to use absolute value with 13 inside of it. We do need it to equal 0.5 on the opposite end, but we also need a variable in there somewhere. So how are we going to approach it? Well, let's see. Use absolute value. So the absolute value of something does have to equal 0.5. I mean, that's absolutely the case here. Now that absolute value needs to relate in some way to 13. But there's got to be something else involved with it, like a variable, so we can actually figure out. I mean, we know the answers, right? The 2 answers are 12.5 and 13.5. Those are the maximum and minimum pressures. That's for sure. The math is easier than coming up with the equation. What about this? And when we think about it this way, we know that the maximum air pressure is 0.5 more than 13, which is 13.5, right? So 13.5 minus 13 is 0.5. We know that the minimum air pressure would be 12.5 because that's 0.5 less than 13. So 12.5 minus 13 would be negative 0.5, but the absolute value of negative 0.5 is 5. So that definitely works. So basically, I have to like work backwards through it to actually write the equation because we already know the answers. And then in terms of solving it, so the absolute value equation, that's what we just wrote right there. And so we've got two cases. We have x minus 13 equals 0.5, and we have x minus 13 equals negative 0.5. So whatever's inside the absolute value bars could be positive 0.5 or negative 0.5. And if we solve for x in each of these, that will give us the maximum minimum air pressures allowable. So add 13 to both sides. 0.5 plus 13 is 13.5. Negative 0.5 plus 13 is 12.5. So let's just say we're down here, and then the air pressure, the ideal air pressure is 13 psi, so we'll just call that 13 in the middle. And we'll just say this one's 13.5, and we'll say this one's 12.5, and then we'll just go ahead and put a dot here and a dot here. And the solution set would be 12.5, comma, 13.5. Now, if we're being honest about this, it's not actually 12.5, comma, 13.5, is it? What should it be? Honestly, this shouldn't be an absolute value equation. This should be an absolute value inequality. Yeah. Yeah. It should be 12.5, 13.5, and then everything in between. So honestly, this one probably should have been part of tomorrow's equations, but that means we're actually going to need to do a solution set of all values of x such that x is between 12.5 and 13.5 inclusive. So that makes more sense because it couldn't just be, the only two solutions here are not 12.5 and 13.5. It could be 13, it could be 13.01, it could be 12.95. So this should have been an inequality. Anyway, we're not going to talk about the rest of this, so we're good there. We've got 5 minutes. With these last 5 minutes, I'm going to tell you which problems I want you to be working on. Again, this is not due tomorrow. This will be due on Thursday. And it would be the same ones that we just had, 1 through 41 odds. One through 41 odds. So if you want to get started on this and solve the equation versions, feel free to do that. We'll talk about inequalities tomorrow. So feel free to get a head start. You got a few more minutes if you want to get started, or if you need to finish up lesson 1 from yesterday, this would be a good chance to work a little bit more on that.